Welcome to the walkthrough for Assignment 2A. The purpose of the first part of this two-part assignment is to deepen your experience using Java functional programming features and their integration with Java sequential streams. In particular, in this assignment, you'll develop an app that uses Java sequential streams to obtain, transform, and store images. The code you write for this assignment has a GUI and runs as an Android app. Please feel free to use this app to help debug your solution. The following resources may be helpful in completing this assignment. Good overviews of Java streams appears here and here, and the book Modern Java in Action is a great resource to learn how to program Java streams. Naturally, we'll cover all this material in class. The Image Crawler app is packaged as a project using Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 2A, however, you only need to be aware of the following directories. Image Crawler crawlers, which contains the skeletons you need to fill in, as described below. Image Crawler source test, which is a set of unit tests that exercise the features you're implementing to evaluate whether you've correctly satisfied this assignment's requirements. And Android source Android test Java assignment test, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created, of course. The app's minimum API is 29, so you'll need to select an emulator that uses an API greater than or equal to 29. I recommend API 30. If you don't already have an Android emulator, you can create one by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here task to provide a working solution. Do not change the overall structure of the skeleton, just fill in the to-do tasks and do not delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the Image Crawler crawlers folder. First, start with Image Crawler's Sequential Streams Crawler.java. Here, you'll need to complete the to-do tasks and various methods to obtain, transform, and store images. This class uses Java sequential streams to perform an image crawl starting from a root URI. Depending on the parameters used to run the tests, images from HTML pages reachable from the root URI are either downloaded from a remote web server or read from the local file system, and the results are stored in the local file system on the Android device. You'll also need to modify the student.kt file, where you'll complete the to-do tag to set the typeset field to include just graduate or undergraduate, depending on which version of the assignment that you're implementing. The bulk of the code for the app is provided in the skeletons. In fact, a complete solution using Java 7 features is provided in the Sequential Loops Crawler file in the Image Crawler crawlers folder. You'll therefore need to focus on converting this Java 7-based class to the Sequential Streams Crawler class that uses Java sequential streams. Your solution should use no loops or no if-else statements in the assignment, and instead use Java sequential stream aggregate operations and functional programming features. Your solution will be considered correct if it passes all the unit instrumentation tests and if you address all the comments I leave for you when I do my review. Skeleton code for this assignment is available here in my GitHub repository. Please set up your GitLab account, pull the skeleton code into your repository, read it carefully, and complete the to-do markers. The unit test and Image Crawler source test are provided to increase our confidence that your implementation is working as expected. You'll need to use the Android Studio GUI to run the unit test locally on your computer, as described here. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the unit test to detect problems in your code. Assignment 2A is designed to deepen your experience developing apps using Java sequential streams and functional programming features. The skeletons and unit tests are quite extensive, though you don't need to understand them all to complete your solution. Please therefore start early and ask questions in class, office hours, and on discussion forums to ensure you complete this assignment successfully. Now that we've walked through the specifications for Assignment 2A, let's go ahead and take a look at the skeleton code. First, make sure you take a look at the Sequential Loops Crawler, which is provided for you an implementation using Java 7. This will demonstrate many of the capabilities and helper methods and so on that you'll need to use in order to implement the Sequential Streams Crawler. So there's a perform crawl method here. As you can see, it checks to see if the max depth is exceeded. It checks to see if the URI that we've got is unique or not using the put-if-absent method from concurrent hash map. And then it recursively calls the crawl page method here. If you take a look at crawl page, you can see there's different arms of this for undergrads and grads. Obviously, you want to take a look at the grad version. This gives you some examples of helper methods to call, like page.getPageElements, as well as calling process image and perform crawl. Naturally, your implementation will not be using loops. It will not be using if-else statements. and so on. Instead, it'll be using sequential streams. But this gives you kind of a feeling for this. Also note your implementation should not be using this image count stuff or this kind of weird hack with a single element array that we use. That's something that is needed when you're doing different versions than when you're using streams. With process image, you can use the get or download image method. Here we have to explicitly check to see if something's null. Your code will not do it that way. It'll use it using a filter, intermediate operation, and so on. And likewise, here we use the for each method on the mTransforms list of transformers and make some calls to create new cache item, apply transform, and so on. So this is here to kind of illustrate what methods you should be calling in your implementation, except your implementation will be doing this using sequential streams and Java functional programming techniques like lambda expressions and method references, rather than using explicit for loops and if-else statements with Java 7 features. So with that in mind, let's now go ahead and turn our attention to the sequential streams crawler skeleton. As you can see here, we have a perform crawl method, and that will kind of be the master of ceremonies and start the recursive crawl for a given page, which is given by this page URI, and it will return the total number of images that are processed at a given depth. So here's kind of a rough outline of what you need to do. You need to create a Java sequential stream that will use a factory method to make a one-element stream that just contains the page URI, and then you use an intermediate operation to filter out the page URI if it exceeds the max depth or if it was already visited. And you, of course, go back and take a look at sequential loops crawler to see the methods you could use there. You'll then use an intermediate operation to recursively trigger the crawling of all images and hyperlinks on this page, returning the total number of processed images. And then you'll use a terminal operation to get the total number of processed images from the one element stream. And that's a big hint there, from the one element stream. And you'll get a chance to kind of chain a couple things together here. Let's go down and look at crawl page. That, of course, will be called up here from this step. And what crawl page is going to do is it's going to use Java streams to download and process images. And actually, it's going to make a helper method call to do some of these things. And here's the crawl page method. It's going to essentially take the page URI and the depth and then return a count of the number of processed images reachable from this page. So here again, you'll use a Java sequential stream that will start by using a factor method to make a one-element stream that just contains the page URI. Then you go ahead and get the HTML page that's associated with the page URI parameter. And the way to do that is to take a look at the sequential loops crawler and see what helper method can help you with that. If you get back a null page, you want to filter that out. And then you'll do a call to process page. We'll talk about process page here in just a second. And as you'll see, the process page method is going to be called in the context of an intermediate operation, and it will process the images that are encountered during the crawl. And finally, you use a terminal operation to get the total number of processed images from the one element stream. And that should look very similar to the same terminal operation that you use here at the end of perform crawl. So let's take a look now at process page. This is really what does the work to download and process the images via process image, recursively crawl the other hyperlinks via perform crawl, and return a sum of all the images processed during the call. This description up here is probably a little bit too detailed for what actually takes place in the crawl page method. The real workhorse method is process page. It takes a page, which was, of course, provided and obtained here in crawl page, and it's going to get a list containing all the image and page elements on the page. It'll convert that list to a sequential stream, and you'll get the list by taking a look at the sequential loops crawler and see how you get a list of page elements given a page. You'll convert that list to a sequential stream. You'll go ahead and map each element to the count of images produced either by processing an image or by crawling a page. And so you'll have to kind of take a look again at sequential loops crawler and see how that code works. Of course, you'll use this in the context of a stream. Do not use if-else statements there. You're perfectly welcome to use the question mark colon or so-called ternary operator. And then finally, you're going to sum all the results together. Let's go take a look at what the process image method does. That's one of the methods that will be called here if you get an image. And so what this does is this will use a Java sequential stream to use a factor method to create a one-element stream containing just the URI, or the URL, I guess I should say URL here. And then you'll go ahead and get or download the image from the given URL. Once again, take a look at Sequential Loops Crawler to see how to do this. Get rid of any null page that may be returned. And then you'll go ahead and make a call with an intermediate operation to transform the image. And we'll talk about that in a second. And that will return a count of the number of transforms that were applied successfully. And then the final thing you do is you'll sum the number of images that were processed by process image. Let's take a look at transform image. That's going to apply a bunch of crawler transforms on the image, and it'll return a count of all the successfully transformed images. So transform image also will use a sequential stream, and it will convert the list of transforms into a sequential stream. And so you want to kind of take a look at the sequential loops crawler to get some hints on how you would do that. Obviously, you'll have to use a stream here, whereas the sequential loops crawler does not use a stream. It uses, I believe, a for each method, but it'll give you a hint as to how to do this. And then you'll use an intermediate operation to attempt to create a new cached item for each image, filtering out any image that's already been locally cached. You'll use another intermediate operation to apply each transform to the original image to produce a transformed image. You'll filter out any null images that were not transformed. And then finally, you'll count the number of non-null images that were indeed successfully transformed. And that's what's going to be returned as the result of transform image. So that's a walkthrough through the various methods here. The comments give you a lot of hints, but you'll have to kind of sit down and think through the various steps that you need to have and what methods to call and what helper methods to call and what intermediate and terminal operations to call, and so on and so forth. So now that we've walked through the specifications and the skeletons for assignment 2A, let's go ahead and run the unit tests. So if we go into the image crawler source test Java folder, and we go ahead and do a little bit right click on this, then we can go ahead and run the tests that are here. You can see it's instantiating the tests. Let me go ahead and make the window a little bit bigger. There's a lot of tests, so it takes a little while to go ahead and instantiate them all. And it's off to the races. You can see it's running all the tests. And if all goes well, which in this case it will go well because this is my master code, so it should work, you should get basically 113 tests, and they should all pass. As you undoubtedly know by now, if some of the tests fail, you'll end up getting indications of what failed and why. You can ignore all these warnings and stuff like that. They don't matter for what we're doing. But you should have all the tests passed. This will, of course, run the tests for both the assignment 1 code, the unsynchronized array and array splitterator, as well as running the tests for the sequential streams crawler. So all should go well. Make sure you run the tests. They will find many interesting problems with your code if you have them. And of course, if you run into any questions, don't hesitate to post them to Piazza.